when I do a query to the data dictionary, I look at the num rows column in user indexes for a particular index for a table that has thousands of rows, and yet it says num rows equals 0. And now, is this a bug? Is it a problem? How do I interpret it? So we'll have a look at that. So let me stop the share on this one. Num 0. So let's start off with a demonstration here. So I've got a table called T. I'm creating it just as a select connect from dual, less than 100. So there's going to be 100 rows in the table using the standard connect by level less than 100 trick that we do for dual. There's 4 columns in there, W, X, Y, and Z. If we actually look at the way we've constructed those columns, each column is populated almost not null, semi not null, etc. So for example, and then we've added a constraint primary key W. So we know W is not null. So if I do a select count star from T, you can see there's 100 rows in there. That makes sense. Let's gather some table stats. And now I'll look at the number of rows from user tables, not user indexes, user tables. And as you'd expect, we've just gathered stats. There's 100 rows in the tables and num rows equals 100. Got to be happy with that. That makes logical sense. Now let's look at the index. So I've got a primary key index on that table, and the number of rows in user indexes equates to the same thing. And that would make sense as well. There's 100 rows in the table, there's 100 rows in the primary key, we have 100 rows. So far, everything seems to be making a reasonable amount of sense. Let's now look at the data distribution of the actual columns in that table. The count of rows in the table is 100, that's count star. The count of rows of X column, there are 70. There are actually 70 not null values in the column called X. 30 of them were left null simply by the way I manufactured the data. Y has 20 values, and Z actually has no values. Even though I created a column called Z, there's actually they're all null in there. Now let's go create some indexes on those columns. So I've got an index IX2 on the column called X. I've got an index IX3 on the column called Y, and IX4 on the column called Z. And I've commented in there the number of non-nulls that we had in there. And here's where the confusion often comes. I'm regathering table stats now. I probably didn't need to, but I regather stats just to be sure. If I now look at the distribution of rows or num rows column in the user indexes table, you can see where the confusion can start to occur. What num rows in user indexes is effectively the number of index entries. Now that's equivalent to distribution of not null columns in the actual index itself. So for the primary key, there's a value for every single row. So the index, there are 100 index entries, and hence num rows equals 100. For index 2, which was the column X, there are 70 not null values. So we don't actually index the 30 null values of X. For a standard B-tree index, if all the entries are null, we don't actually create an index entry in there. In fact, you could actually argue that index number 2 is actually smaller than the table itself, because it only holds 70 entries and not 100. Index 3 similarly has 20, and index 4, you can see this is where the confusion of the question came in originally. There are no values for the column called Z, so the index IX4, which was on column Z, has no rows in it. The index is effectively empty. You'll see this from time to time, not just on columns that are all null, but for example, if I add a new column, so here I've added a new column called new column, it's of type integer, and obviously by default when I add a new column, there's no values in it. So I create an index on that new column, gather table stats again, and now you can see that IX5 also has num rows equals 0. That's probably the most common time I see it, when you've added a column and there's an index on it, for example, a foreign key index, etc. If you haven't populated that column yet, num rows will be equal to 0. It's unlikely that that column will stay null, you'd imagine, because a column which is always full of null values probably isn't very useful. In terms of where that num rows figure comes from, you need to also consider when it comes to composite indexes. I've created an index here called IX6 on columns Z, X, and Y. The way an index works, you could conceptually think about it as the index key being the concatenation of those 3 columns. So if I was to concatenate Z, which is all null, X, which has 70 values, not null, and Y, which has 20, it turns out that if I concatenated those 3 values, I ended up with 70 rows that were not null. So you can see that for IX6, the second last row in the query from user indexes, it also has a num rows of 70. If we had, say, 20 not null rows for Y and 80 not null rows for X, but there was an overlap between those 20 and the 80, we might come up with some other number like, say, 95 or 92. but it is effectively the logical concatenation of those values. Do they all come out, or any of them come out as not null? That would result in an index key. And as a result, you would get num rows not being 0, or num rows in the index being equivalent to the number of not null entries of that concatenation. So hopefully that makes sense. And it's important to realize, because that figure being different to actually the number of rows in the table helps you then define, or helps the optimizer define, how good that index might be for use. Because sometimes an index might be very small compared to the overall size of the table if a lot of the values for the columns being indexed are null. That can make that index very attractive when it comes to, for example, if I do select count of an indexed column from a table, the database might quite simply say, well, why would I scan the whole table? Maybe it's better just to scan this smaller index, either with a range scan or maybe a fast full scan. So knowing that an index is actually smaller than the size of a table is useful for the optimizer, and hence your query performance.